This is part 3 of section 6.5. We have been dealing with determinants, but so far we've only done 2 by 2. We're now going to start on 3 by 3. You're going to find more than likely that the method I show you for solving a 3 by 3 determinant is different from what you will see in the book or even in Help Me Solve This or View an Example. What they show you is a method that expands up until if you want to take a determinant of a 4 by 4 or a 10 by 10. It's a process called expansion by minors. I'm not going to show you that. There is a trick for doing a 3 by 3, and in this class, we're not going to do anything larger. Okay. Now, if you want to look in the book or watch the videos or use Help Me Solve This and figure out how to do it the other way, that's perfectly okay. But this will get you through a 3 by 3. Okay, the first thing you want to do is you want to recopy your first 2 columns over here. Now you want to do it very neatly because we're going to have to line some things up. So I'm going to recopy 4, 3, 2, and then 0, -1, and -3. We don't need to recopy our third. Okay. Now what we're going to do is going to feel a little bit similar to what we did before. Okay. This determinant is going to equal. I'm going to open parentheses. Now I'm going to go in this direction like we did before. Remember when we were doing a 2 by 2, we went this way and subtracted this way. You're going to see something kind of similar. I'm going to multiply on this diagonal. Okay, and I'm actually going to do the calculations here because if I continue to write out the multiplications, this is going to get so ugly you're not going to be able to follow it. So 4 times -1 times 5, so I'm multiplying all of these, that gives me a -20. Okay, now inside these parentheses we're going to do a plus. We have more diagonals that go in this direction, so now I'm going to do 0 times 4 times 2. Well, I don't even need to multiply because I'm multiplying by a 0. That's going to be a 0. And then plus, I have one more diagonal that goes that direction, one more complete diagonal. 0 times 3 times -3 is 0. Okay? And I close parentheses. Notice I don't have any more diagonals going this direction that have 3 in them. Everything else has 2 or 1. Once you've taken care of these 3 diagonals, adding their products together, then you go subtraction, and now we're going to go back the other way. So we add when we're going the same direction, we subtract when we're going opposite directions. Okay? So now I just reverse it. I look for my first main diagonal that has 3 in it, so not here, but here. 0 times -1 times 2 is 0. I'm going to go the same direction. 4 times 4 times -3. And that will be -48. Plus, and now one more in that diagonal. 0 times 3 times 5 is 0. Now we've got zeros in here, which is of course very nice, but just be careful with your signs, and you've got -20 minus a -48, which is -20 plus 48, which will equal 28. So the determinant of our original matrix is 28. Let's do this one. I want to find the determinant of this 3 by 3, and so I'm going to recopy our first 2 columns, and then I'm going to start going on the from up left to down right. 1 times 2 times 1 is 2. Plus, remember plus is inside the parentheses. 2 times -3 times 3 that is negative 18, plus 3 times 2 times 2, which is 12. Now we're going to go in the other direction, so minus, open parentheses again, 3 times 2 times 3 is 18, plus 1 times negative 3 times 2 is negative 6, plus 2 times 2 times 1, which is 4. Now do your arithmetic inside your parentheses. 2 plus negative 18 plus 12 gives me a negative 4, minus 18 plus a negative 6, or 18 minus 6, plus 4 is 16, positive 16. So this is negative 4 minus 16. The determinant of our original matrix is negative 20. Okay, so let's talk about Cramer's rule with this. It's very similar, although it looks horrible. Okay, but we just have so many different pieces in here. But we're doing essentially the same thing. We just have larger determinants to take, and we're going to have to find an extra determinant so that we can find our z-value. Okay? We still make our d determinant by writing the matrix with all of our coefficients. It's going to be 3 by 3 because we now have z-values. Okay? We find our dx by taking this column and covering up our x column. So notice our d's here are in our x column, and that goes with this. For dy, our d's are in our y column. We covered up our y's. And then for dz, we cover up our z's. So there's an extra determinant to take here. But then once we have all four, dx over d, which is the same formula we had before, dy over d gives you y, exactly the same. And it's just, then what you would probably guess, dz over d gives you the z value, sorry. Okay. So let's try this last one. Okay. I do a quick check to see if everything is here and it's in the right order and we look good. So my d is going to be 1, 2, negative 1, negative 1, 3, negative 1, 2, 1, 3. And this is the first determinant we need to calculate. Okay, now to calculate this, I shouldn't have put the equal sign right there. We're going to recopy our first two. So I have 1, let's see if I can turn that into 2. Not bad. Negative 1, and then negative 1, 3, negative 1. And we are going to do what we did in the last section. We're going to open our parentheses. 1 times 3 times 3, that is 9. Plus negative 1 times negative 1, that's positive 1. Plus 2 times 2 times negative 1, and that will be negative 4. Minus, open parentheses, and we're going to go back the other direction. 2 times 3 times negative 1 is a negative 6, plus 1 times negative 1 is negative 1, plus we have negative 1 times 2 times 3, which gives me a negative 6. Okay, so let's simplify. That's 10 minus 4, that's 6. Minus, it's going to be negative 12, negative 13. So minus a negative 12 is plus 13. So my d value is 19. I don't want to lose it, so I'm going to box it. There's going to be a lot written. That's the first thing I need in order to be able to solve this whole thing. It's not 0, so I should be getting some sort of solutions.